In this video, we're going to talk about section 1.5, which involves solving inequalities. So first, we need to look at what type of inequalities that we'll see in this section and actually in the next section as well. And we've talked about this, or we've mentioned this on and off throughout the class, why these are important. And so if you look at the first inequality over here, a is less than x, which is less than b, you'll see that those are strict inequalities. And then in the interval representation over here, strict inequalities are represented, at least at the endpoints, with parentheses. Yes, and so I've talked about this a lot. This is not the parentheses a comma b is not the point a, b. It is the range of numbers between a and b. Okay? Yeah, so b there. Sorry about my terrible handwriting. Okay? So those parentheses give us an interval, not an actual point. So remember, especially when we're talking about inequalities, we're not going to be talking about points, but intervals. So there's that. Less than or equal to inequalities here correspond to brackets instead of parentheses. And so then in the third and fourth one here, you see different combinations and how those intervals change. Okay, their endpoints change. And then when we move down to here, the second four, you see that when I have not x being in between something, but either greater than or less than, you'll see that the interval representation, or wherever sort of the inequality points to, at the end is either going to be infinity or negative infinity. Okay, and so I'm not going to dwell on each of these and talk about them because I think we have a good understanding of what they mean. But we're going to use inequalities, or we're going to try to solve for inequalities. So what do I mean by that? Well, let's look at a number of examples here. So what I eventually want when I say solve these following inequalities, what I really mean is find all the values. You say find every value of x that makes these statements true. Okay, so for what values of x, where x could be what I could possibly plug in or substitute into these equations, are anything from negative infinity to infinity. I want the values of x which make this true, okay, or this or this. So we have three different examples, and so what we're going to do in your mind, sort of, you should think of this as trying to solve 3 minus 2x equals 5. What would you do? Okay, so you have a number of steps that you're used to when you solve this equation here, but instead of an equation, I now have an inequality. The same rules apply. Okay, for the most part, there are a few different ones, or a few ones that you have to keep in mind when solving for these inequalities, but on the whole, it's going to be just like solving an equation, okay? Or solving an equality. Now we just have an inequality. So I want to get x alone. Okay? I want to get x alone. That's going to give me the values that I want. So when I have a strictly I have just one inequality here, either less than or greater than, not in between some things. Okay, I want to get x alone, and so the first step I need for, we'll call this one number 1. Here, We'll call this number 2, and we'll call this number 3. So problem 1, I've got 3 minus 2x is less than 5. I like to rewrite my problems just so I've got some more room here. So I want to get the x alone. I subtract 3 from both sides, and so I get negative 2x is less than 2. Okay. As long as I do it to both sides, nothing changes. And now here comes the tricky part. If you would imagine the less than sign as an equal sign, what you would do is you'd divide by negative 2. Okay, and so we do that, and then what we get when we divide by negative 2 is an x on the left and a negative 1 on the right. But the important thing to remember here, so I'll give it some stars, is that when I divide by a negative number, the inequality switches. Maybe switch is not the best word. The inequality flips. Okay? So before I had negative 2x is less than 2. When I divide by a negative number, it flips the inequality sign to be greater than. So what I work down to, and what sort of the final answer is that x is greater than negative 1. Okay. Now, like always, it's important to, and I'll erase this fact. So if you didn't write that down, you should. So back up the video and write it down before I erased it. But back to my point, you should check and see if these range of values work. Okay, so x greater than 0, is that true? Or sorry, x greater than negative 1. Are all those values true? So pick a couple. So what values are greater than negative 1? Well, we could try 0. If you plug 0 in there, you get 3 minus 2 times 0, which is 0. Or 3 is 3 minus 0, which is 3. Okay, so is 3 less than 5? Yes. Okay, so 0 works out when you substitute 0 in. What about something like 2? Okay, 2 times 2 is 4. 3 minus 4 is negative 1, and negative 1 is definitely less than 5. So it looks like, I've picked a couple points. It looks like it worked. Okay, I can also try what if the number is less than negative 1. Okay, does that make it false? And so if I plug in something like negative 2, then I get 3 minus negative 4, and that's really 3 plus 4, which is 7, and 7 is not less than 5. So it all works out. It looks like I have the right sort of interval. So this is good. We've checked it. Okay. The last thing that I want you to do is to graph this on a number line. Okay. And so I'm not asking for you to make a whole number line for every problem and write it down, but for every one that you do, we have a little line here, okay, a continuum, and you only need to write down the sort of important points here. And so we'll start with maybe 0 here and negative 1 here. And so this says that x has to be greater than negative 1. So how you should do that, and I'll do it by changing colors here, is that at the point negative 1, you should have an open dot, because it doesn't include, this is greater than, not greater than or equal to. So it's an open dot at negative 1, and then you shade in everything that's true. And so everything that's true is greater than negative 1, so I shade that in, put an arrow at the end, and there is my there's the graphical representation of what we did. Okay, so there, now that is what I consider as like a fully done problem for solving inequality. So we found the actual inequality, or the range of values that make this statement appear, number 1, true, and then we graphed it. And so that's what we're going to do for each of them. So if we move over to number 2, we get something a little tougher. Okay? There's x's now on both sides, but all we need to do is get the x's over onto one side, the numbers to the other, and then solve like we usually do. So if you're having trouble visualizing what you do, stick an equal sign in here for the inequality and then try to solve. So I'll write it down again just for my own sake. I'm going to get the x's on the left, get the x's over here, and then the numbers over here. So I need to subtract by 2x on both sides and subtract by 7 on both sides. So 4x minus 2x is 2x. Okay. The greater than or equal to is still there, and then I subtract away the 7, and so negative 3 minus 7 is negative 10. Negative 10. And then to get x alone, I divide by 2. And because I divided by a positive number, the inequality stays the same. Okay? And so I get x greater than or equal to negative 5. And so then that's my answer. Let us test. We'll test it out with 0. If you substitute 0 in, all the x stuff goes away, and you're left with 7 greater than or equal to negative 3. That certainly is true, so you've picked the right direction. Okay, you could and should try, if you have time, more values and make sure that that's true, but I'm going to skip ahead because I believe in myself, and you should too, but just to be safe, do it multiple points. Okay, now let's draw our small line here again. Okay, our point that we're interested in is, we'll put right here as negative 5. This says x is greater than or equal to negative 5. So here, what I put is a filled in point, okay, and then a line in the direction where we're going. Okay, you should add, I guess, a second number down here. This is negative 4 to show which direction that line is pointing in. Okay. Okay, so that's number 2. Now let's move on to number 3. Number 3 is a little bit different because it's having x be between two numbers. And so the arithmetic that you do is a little bit different. Okay, so when I have, negative 5 is less than 3x minus 2, which is less than 1. Get rid of that second negative in there. Okay, so now we have negative 5 is less than 3x minus 2, which is less than 1. Okay, I still want to get x alone in between the inequalities now. Okay, and so I have to do the regular operations that I was doing on the first two. For instance, my first operation would be to add 2. But when I do that, I actually have to do it to both things outside of my inequality. So I have to add 2 over here and add 2 over here. Okay? So when I do that, I get negative 3 is less than 3x, which is less than 3. Okay? And to get x alone, I divide by 3. But again, I need to divide both of these endpoint things by 3. Okay? So I get negative 1 is less than x, which is less than 1 as my final answer. Okay, so get x alone. We've done that here. So what makes the statement true, the statement number 3 up here, the original statement true, when x is between negative 1 and 1, not including those points. So again, we could try 0, but when we substitute 0 in, we get that negative 5 is less than 3 times 0, which is 0 minus 2, which is negative 2. So negative 5 is less than negative 2, and negative 2 is less than 1. So 0 works out. And then, of course, you could try and substitute in these endpoints, negative 1 and 1, to make sure that they don't work. And sure enough, if you substitute in positive 1, you get that negative 5 is less than 3 minus 2, which is 1, so that's certainly true. But 1 is not less than 1. It's equal to 1. So that second statement here would not be true. So it works out. It looks like it's right. And so now we want to make our small number line here again. Now we have a couple of points that we're interested in. Negative 1, 1, and we'll put 0 in here for good measure. Okay, and so the interval here, because it's less thans on either side, both of the endpoints have an open dot. Okay, so both have open dot, and so you shade in the area again that matches, and so there we go. Okay, so those are 3 different examples of solving inequalities, and so, as you may guess, the next slide is a your turn. So for this your turn, I want you to solve the inequality just like I solved those other 3.